Download this code from codegive.com, link in the description below. Python HTTP error 400 bad request, a deep dive with urllib and solutions. HTTP error 400 bad request signifies that the server couldn't or wouldn't process the request due to something wrong with the request itself. This isn't a server-side error, like a 500, the problem lies in how you're sending the request. Using Python's urllib library, let's explore common causes and solutions. Understanding the 400 bad request. A 400 bad request can stem from various issues. Incorrect request method using post when get is expected, or vice versa. Malformed request data missing required parameters, incorrect data types, exceeding length limits, or improperly formatted JSON/XML. Invalid request headers incorrect content type, missing authorization headers, or conflicting headers. Client-side validation failures the client, your Python script, didn't properly validate the data before sending the request. Server-specific limitations the server might have restrictions on request content that aren't documented in the API. Reproducing the error with urllib. Let's create a scenario to demonstrate a 400 bad request using urllib.request. We'll simulate a faulty post request to a hypothetical API. This code intentionally omits a required field, example email or age. When you run this against an API expecting that field, it'll likely return a 400 bad request. The try, except block gracefully handles the error, providing valuable diagnostic information, the HTTP status code, reason, headers, and, if available, details from the server's error response. Debugging and troubleshooting 400 errors. 1. Inspect the error response the server's response, accessible through e.read, in the except block, is crucial. It often includes detailed explanations of why the request failed. Try to parse the response as JSON, as shown above, or XML to access structured error messages. 2. Check request method ensure you're using the correct HTTP method, get, post, put, delete, etc. The API documentation will specify the appropriate method. 3. Verify request data carefully review your request data for missing fields, incorrect data types, or exceeding length constraints. Use a tool like Postman to test your requests independently of your Python code. 4. Examine request headers pay close attention to headers such as content type, especially for JSON or XML, authorization, if authentication is needed, and any custom headers required by the API. 5. Validate client-side data before sending the request, rigorously validate your data on the client side. Ensure all required fields are present and of the correct type. 6. Inspect server-side logs if you have access to the server logs, check them for more information about the failed request. Example of fixing a 400 error. Let's fix the previous example by adding the missing email field. This modification will likely resolve the 400 error if the missing email was the sole problem. Using libraries like requests. While urllib is a built-in option, the requests library is generally preferred for its ease of use and richer functionality. Requests simplifies the process, handles JSON encoding automatically, and provides more helpful error handling. The response.raise_for_status method conveniently raises an exception for non-2xx status codes. Remember to install requests, pip install requests. By systematically examining your request and utilizing the error handling provided by urllib or requests, you can effectively diagnose and resolve HTTP 400 bad request errors in your Python applications. Always consult the API documentation for specific requirements and expected request formats.